Today, we're going to discuss the chain rule. So let's start from the definition. If y equals f of u is a differentiable function of u, and u equals g of x is a differentiable function of x, then y equals f of g of x is a differentiable function of x, and dy over dx is equal to the product of dy over du times du over dx, or it is equivalently to d over dx of f of g of x is equal to f prime of g of x times g prime of x. Now, to understand better, let's put this one into example. So we are going to use the chain rule to differentiate r of z is equal to 5z minus 8. So first, we are going to rewrite the radical form into fractional exponent. We know that r of z is equal to the quantity of 5z minus 8 to the power of 1 half. Now we take now the derivative of that. So r of z is equal to, using power rule first, so we have now 1 half times the quantity of 5z minus 8, and then subtract the exponent by 1. So 1 half minus 1 equals negative 1 half. Then you take the derivative of the base, which is now 5z minus 8. Or we're going to take the derivative of the radicand. Now, the derivative of 5z minus 8 is equal to, derivative of 5z is 5, and derivative of negative 8 is equal to 0. So therefore, we only have to multiply this one now. So the final answer of this, we have the derivative of the given function is equal to 1 half times 5 is equal to 5 over 2 times the quantity of 5z minus 8 to the power of negative 1 half, or that is equivalent to 5 over 2 times the square root of 5z minus 8. So you can choose which of these two answers you are going to present, but they are still the same. Now for number 2, we are asked to find dy over dx for y equals the quantity of x squared plus 1 to the power of 3. Take note, the notation for derivative, it could be written as dy over dx, or sometimes y prime, or sometimes it depends on the given of the name of the function. So like r of z, so it could be written as r prime of z. Now for number 2, we are asked to write dy over dx. So therefore, we have dy over dx is equal to, apply first power rule. We have 3 times x squared plus 1, and then subtract the exponent now. We have 3 minus 1 equals 2. Then after that, we're going to use now the chain rule. So from the power rule, the second one now is the base, which is now x squared plus 1. So taking the derivative of x squared plus 1, so derivative of x squared is 2x, and derivative of 1 is 0. So therefore, we can now simplify or multiply the monomials, which is 3 times 2x. So therefore, our derivative now will be 3 times 2x, we have 6x, times the quantity of x squared plus 1 that is raised to the power of 2. So this is now the derivative of the given function. Okay, next example. So we have the given function is f of x equals sine of 3x squared plus x. So in this case, class, first we are going to take the derivative of the trigonometric function followed by the angle. So therefore, f prime of x will be equal to, first, as I've said, take the derivative of sine of the given function. So derivative of sine is equal to cosine, write the angle. We have 3x squared plus x. And then after that, you take the derivative of the given angle, which is now 3x squared plus x. So take the derivative for that. So derivative of 3x squared equals 6x, and derivative of x is 1. So there's a sign of positive, so therefore plus 1. So multiplying that one, we are going to rearrange our result. So let us write first algebra before trigonometric function. So therefore, I can write now as the quantity of 6x plus 1 times cosine of 3x squared plus x. Okay, so the next example is f of t. So we can write our notation as f prime of t is equal to, so multiply the exponent to the coefficient of this quantity. So therefore 50 times 1, because the coefficient is only invisible 1. So therefore 50 times 1 is 50, times copy the entire base, which is now 2t cubed plus cosine t. So we can write now here as 2t cubed plus cosine of t, and then to the power of 49, because we subtract 1 to the exponent. So 50 minus 1 is 49. Then we take down the derivative of each term from the base. So our base now is the quantity of 2t cubed plus cosine t. So the derivative of 2t cubed now is equal to 6t squared, and then derivative of cosine t is negative sine t. So negative times positive becomes now negative sine t. So in this case, since the angle is t and we know that derivative of t is just 1, then times no need to write here times 1, because a number multiplied by 1, it will just give us the same kind of number. So you can rearrange this one as 50 times 60 squared minus sine t times the quantity of 2t cubed plus cosine t to the power of 49. Or you can write your answer. You can remain this one if you want. So next we have g of x is equal to ln of x to the power of negative 4 plus x raised to 4. So we apply here the derivative of the natural logarithm. So we can write now g prime of x. Since it is ln, we know that derivative of the ln, first step is to take the reciprocal of the angle. So the reciprocal of the angle now will give us 1 over x to the power of negative 4 plus x raised to 4. Then after that, we are going to take the derivative of this angle. Okay, so we have to take the derivative of this. So start from the first term. So derivative of x to the power of negative 4. So apply power rule. So we have now negative 4. X to the power of negative 4 minus 1 is negative 5, plus the second term now is x raised to the fourth power. So apply power rule as well. So 4x to the power of 4 minus 1 is 3. So multiplying that one now, it gives us the product of negative 4x to the power of negative 5 plus 4x to the power of 3 all over x to the power of negative 4 plus x to the power of positive 4. Okay, the next one we have y equals secant of 1 minus 5x. So we can write now y prime as a symbol for derivative. So is equal to, start finding the derivative of the trigonometric function followed by the measurement of the angle. So we know that the derivative of secant u, if u is a name of the angle, is equal to secant u tangent u. So therefore, I can write now as secant of the measurement of the angle is 1 minus 5x, tangent of 1 minus 5x, and then take the derivative of the angle. They are just the same. So actually, we are referring to this measurement of angle. So we can write now as, so derivative of 1 minus 5x is just equal to negative 5. So multiplying that one now, let us start writing the monomial, which is the algebraic term, which is now equal to negative 5 secant of the measurement of the angle is 1 minus 5x tangent of 1 minus 5x. So that is now the derivative of the given function. So next one we have p of t is equal to cosine to the fourth power of t plus cosine of t to the power of 4. So it looks like confusing, but take note, the first term we have the trigonometric function was raised by the power of 4, while on the second term it is the measurement of the angle t that is being raised to the power of 4. So actually the two terms are not the same. So to solve for that, we have now p prime of t. Let us start first with the first term. So since there is an exponent is greater than 1, then we have to take the power rule first. So we can write now as 4 cosine of cosine cube of t times the derivative of the trigonometric function. So we know that the derivative of cosine is negative sine. So you can write now negative sine t. And then since the measurement, the angle is just t, we know that derivative of t is 1, then no need to write 1. But just in case, if the measurement of the angle will not give us a derivative of 1, then we have to use again the chain rule. So that is now for the first term. Now on the second term, we have plus, we have cosine of t raised to the fourth power. Since cosine here has only the exponent of 1, then we are going to take right away the derivative of cosine. We know that the derivative of cosine is negative sine. So I can write here now negative sine of t raised to 4. So the measurement of the angle is t raised to 4, and that is still differentiable. So, okay, so taking now the derivative of t raised to the fourth power to complete our answer. So we have now 4t cubed. All right. So after that, we're now going to simplify. So we can just write now as 4 times negative sine t. I can write negative 4 sine t of cosine cube t. Then positive times negative is negative. Negative times 4t cubed. So I have now negative 4t cube of sine t raised to the fourth power. And that would be now our answer. Next, we have t of x is equal to the arctangent of 2x times the cube root of 1 minus 3x squared. So in this case, we are going to apply the product rule since the first factor is arctangent of 2x and the second factor is the cube root of 1 minus 3x squared. Now, if we're going to apply what we have learned in our product rule, so this is our u and this is our v. So following the formula for the product rule, we have u dv plus v du. Now, we can write t prime of x is equal to u, copy the meaning of u, we have now the arc tangent of 2x times the derivative of v. We have dv, so we have this is cube root, therefore we can write now as the quantity of 1 minus 3x squared to the power of 1/3. This one can be written as, so I will just write here on the other side, that the cube root of 1 minus 3x squared is written as 1 minus 3x squared. The quantity of this is raised to the power of 1/3. So therefore, I will write first 1/3 times the quantity of 1 minus 3x squared to the power of, we have here 1/3 is the exponent, to the power of 1/3 minus 1 equals negative 2/3. So I have negative 2/3. Then after that, we are gonna use chain rule. So we start from the power rule and then we're gonna take the derivative of the base. So derivative of 1 minus 3x squared, so derivative of 1 is 0, and the derivative of negative 3x squared, it gives us negative 6x. So this is still the answer of u dv. Now, the second term, we have plus v du. So copy the v. We have the cube root of 1 minus 3x squared times the derivative of u. So we have to write first the derivative of arctangent. Arctangent of u is just equal to u prime over 1 plus u squared. So in our case, our u will let u is equal to 2x according to our given. Now u prime is just equal to du. Du or just equal to u prime, which is now equal to 2 dx or just 2. Or we could write du over dx just equal to, or du equals 2 dx, or simply write u prime is equal to, or simply write u prime is equal to 2. Now we can write now here. So this is now our v du. So this is our v times our du now, which is the arctangent of 2x. So we can write this formula. So following this formula, the u prime now is equal to 2 over 1 plus u squared. We know that u is 2x, so I write here first 2x, and then it will be squared. So we have now the u dv plus v du. So simplifying that one now, we have here the numerical coefficient of 1/3 times negative 6x. So it gives us now negative 2x. So I have negative 2x. I write now the arctangent of 2x times the quantity of 1 minus 3x squared to the power of negative 2/3 plus the product of this. So we have 2 times the cube root of 1 minus 3x squared all over 1 plus the square of 2x means 4x squared. So that is now the derivative of the given function. So we applied here u dv because there are two factors in the given function. So next one we have here, y is equal to the quantity of x cubed plus 4 to the power of 5 all over the quantity of 1 minus 2x squared to the power of 3. So since that is a rational function, we are going to apply the quotient rule. We know that the numerator is our u and the denominator is our v. So following the format of v du, we have v du minus u dv. So we have now y prime. Our v is the quantity of 1 minus 2x squared close to the power of 3 times our derivative of u. So derivative of u, this is our u. So take the derivative of that. So I will just write it directly because if I'm going to start writing d over dx, then it will become a very long solution. So I guess you can manage how to solve it directly. Now this is our v, then derivative of u. So look at this, the one that I highlighted, that's the numerator. So the derivative of that now becomes 5 times the quantity of x cubed plus 4 to the power of 4 because 5 minus 1. Then apply another chain rule. So the derivative of this base, we have x cubed plus 4. So times derivative of x cubed is 3x squared. Derivative 4 is 0, so no need to write. Now we are done with the v du. So the second term now is u dv. So I'll write here minus, copy the u, which is now the quantity of x cubed plus 4 to the power of 5. That is our u. times dv. So we are now talking here about taking the derivative of the denominator. So this is where this is our v, then we're going to take for the derivative of that. So the derivative of that denominator, so we have start first with the power rule. So I can write now as 3 times the quantity of 1 minus 2x. And then the exponent now will be subtracted by 1. So 3 minus 1 is equal to 2. Then after that, we are going to take the derivative of this base. So the base now we have 1 minus 2x. So derivative of 1 is 0. And derivative of negative 2x just negative 2. So we are now complete in our numerator. This is now v du minus u dv all over all over the square of v. So we can write now as 1 minus 2x squared. The quantity of this is raised to the power of 3 according to the given, but that is still v. But we need to square the v, so we can write now the quantity of the given denominator will be raised to the power of 2. So simplifying now our numerator, let's start first with the numerical coefficients as well as the monomial. So we have 5 times 3x squared will give us 15x squared times, I'll copy the next term, we have 1 minus 2x squared to the power of 3. And the next one we have x cubed plus 4 to the power of 4 minus I'll multiply this one first. 3 times negative 2. So we have negative 6 times negative. It becomes now positive. It becomes now positive 6 times, copy the next binomial. We have x cubed plus 4 to the power of 5 times. The next one is we have 1 minus 2x to the power of 2 all over. So we have to apply power to a power rule. So we're trying to multiply this one, then 3 and 2. So power to a power rule, we need to multiply their powers. So 3 times 2, it becomes now to the power of 6. So I'll copy the base. We have now the quantity of 1 minus 2x squared to the power of 6. Now, if you want to simplify further our numerator, then we are going to find the common factor. So let's start first with the monomials. So I have here, we have 15x. The monomials now here, we have 15x squared together with 6. So the common factor between 15 and 6 is just 3. And okay, correction for in this part, we have here on the minus, we have u dv. Our u here is x cubed plus 4 to the power of 5 times the derivative of v. We have 3 times the quantity of 1 minus 2x squared, which I forgot the power of 2 a while ago. And then this will be raised to the power of 2. And then taking the derivative 1 minus 2x squared, it is not negative 2, but it should be negative 4x. So this is now negative 4x. And then we have to multiply. We have 3 times negative 4x is negative 12x times negative outside. It becomes now positive 12x. So we can write here now positive 12x. Now, we are going to find the common factor between 15x squared and 12x. So numerically, 15 and 12, the common factor is just 3. And between x squared and x, so we have x is the common factor. And then look at here the binomial. So we have here the we have 1 minus 2x squared, and we also have 1 minus 2x squared. I am just, there's a lacking of power of 2 here. Okay, so they are now the same. All right. So since they are just the same base, we have 1 minus 2x squared to the power of 3 and 1 minus 2x squared to the power of 2. We are going to take the smallest exponent. So it happened that the smallest exponent between this one, power of 2, and the power of 3. So we take the power of 2 because it is the lowest exponent. So therefore, I can write here now as one of the factors now we have 1 minus 2x squared, the quantity of this to the power of 2. Now we are done the first factor, the second factor. Now let's move on to the third factor if they have the same term on the second term. So we have here x cubed plus 4 to the power of 4. And we also have x cubed plus 4 to the power of 5. So between the two, the lowest exponent now is to the power of 4 between these 4 and 5. They are of the same base, so we can have a common factor now. So the common factor now, we have the quantity of x cubed plus 4 to the power of 4. So all of this, we have the 3x times the square of 1 minus 2x squared, and the fourth power of x squared plus 4 are what we called as the common factors of the numerator. Now, we're going to divide the numerator divided by its common factor. So it starts first with 15x squared divided by 3x. So the quotient now we have 5x. And then the second factor, we have the cube of 1 minus 2x squared divided by the square of 1 minus 2x squared. So we still have 1 to the power of 1 of this binomial. So I can write now 1 minus 2x squared. On the third factor, we have the fourth power of x cubed plus 4 divided by the fourth power of x squared plus 4. So since they are the same base and the same exponent, so it is just equal to 1, or we can just cancel out. So no need to write 1 in this part because this is a product form. So 1 times these other factors will give us the same factors. Now on the second term, we can write now plus. So again, we have to divide first on the numerator, the monomials. So 12x divided by 3x. So the quotient is just 4. And then the second term, so we have x cubed plus 4 to the fifth power and divided by the quantity of x cubed plus 4 to the fourth power. So we still have a remaining one factor of x cubed plus 4. So I can write here x cubed plus 4. And the next term here, we have the square of 1 minus 2x squared. And we also have here the square of 1 minus 2x squared. So since they are the same, so the result of that is just equal to 1, then no need to write 1. Then I'll copy the overall denominator, which is we simplified earlier already. So we have now the quantity of 1 minus 2x squared to the power of 6. So we can still simplify further by simplifying here inside the bracket. So by simplifying that one, so we can write now here, so is equal to, I'll copy the first three terms. So we can write now 3x times 1 minus 2x squared to the power of 2 times x cubed plus 4 to the power of 4. And then simplifying inside the bracket. So we have now 5x times 1. I have 5x, and then 5x times negative 2x squared gives us the product of negative 10x cubed. And on the second term, we have 4 times x cubed is 4x cubed. Then 4 times 4 is 16. All over the denominator, which is now the quantity of 1 minus 2x squared. And then this will be raise the power of 6. So by simply looking at the inside the bracket, I think we can simplify it further. So I will just write the answers on top. So on this part, so we have I'll start first with 5x, so there's no common term, so we just write here 5x, and then negative 10x cubed plus 4x cubed is equal to 6x cubed, and then the last term now is 16. So if you want to write the final answer, so you can write now as, instead of writing this one, so you can have another step as your final answer. So the final answer now for this derivative of this function will be equal to 3x times the quantity of 1 minus 2x squared. The quantity is raised to the power of 2 times the quantity of x cubed plus 4 to the power of 4 times the simplification of this, we have 5x minus 6x cubed plus 16 all over the 6th power of 1 minus 2x squared, or the quantity of 1 minus 2x squared raised to the power of 6. So it gives us a very long solution. All right. So I hope you're able to follow. So I need to discuss this one. This is quite different from the from the previous example. Now let's try. So the given function is equal to the entire of the rational function is raised to the power of 3. Unlike a while ago, so the exponent of the numerator is different from the exponent of the denominator. So in that case, since rational function, the numerator and denominator are of the same exponent, so apply first power rule before taking the derivative of the numerator and the denominator. So actually we are using here the chain rule. So in chain rule, we always start with the power rule. So we can write now. So the derivative of this function is equal to 3 times, copy the base. We have 2t plus 3 all over 6 minus t squared. And then the exponent here will be subtracted by 1. So 3 minus 1 is equal to 2. Now next is, so we need to take the derivative of the rational function. Since this is a quotient rule, so this is a rational, then we are going to apply the quotient rule. So we know that the quotient rule is, let us write here again to recall, we have v du minus u dv all over the square of the denominator. So to follow that one, so I will write here now times, I will write the v, which is now the denominator. So the quantity of 6 minus t squared times the derivative of u. So looking at this, you solve it mentally. So the derivative of the numerator, which is the d, this now numerator is u, so derivative of that is du. So derivative of 2t plus 3 will just give us 2. Derivative of 3 is 0, so a total of, so derivative of that now just 2 minus, we have u dv. So I'll copy the u, which is now 2t plus 3 times derivative of v, derivative of 6 is 0, derivative of negative t squared is negative 2t, all over, copy the denominator, which is now 6 minus t squared, and then you square the v. Now, we need to simplify our v du minus u dv. So I'll copy first this one. So we have 3 times the quantity of 2t plus 3 over 6 minus t squared to the power of 2. So simplifying this one, so we have 2 times 6. So we can write here as 12 minus 2t squared. This one is 2t times negative 2t is negative 4t squared times negative. So it becomes now positive 4t squared. And then 3 times negative 2t is negative 6t times negative outside. It becomes now positive 6t. All over, we have the quantity of 6 minus t squared to the power of 2. So simplifying further in the v du minus u dv, so I can write now We have copy the first factor. We have 3 times 2t plus 3 over 6 minus t squared. And this is raised to the power of 2. So we can start now with the constant term. So I can write now as we have 12, or maybe we can arrange it first from the highest exponent to the lowest exponent. So I have here negative 2t squared plus 4t squared is equal to 2t squared plus 6t plus 12 all over we have 6 minus t squared to the power of 2. Now, if I want to factor out, since there is a common factor of this, we have 2, 6, and 12. The common factor is 2. But the result of that, okay, if I'm going to factor out, I will just write this as my scratch. So I can write now 2 times t squared plus 3t plus 12 by 2 is 6. But looking at these factors, so I cannot factor it further, wherein I can make a cancellation after that. But since there is no factors or that I can cancel something after I factored, then I will just remain the numerator as 2t squared plus 6t plus 12. But in case if you attempt to factor out, then it happened that we can make cancellation after factoring, then you have to factor. But it just in case, if in case you can see that there is no cancellation after you factor, then you better stop up to that point so that yours it will not give you a very long solution. Maybe what I can do it here now, since the denominator have the same binomial which is 6 minus t squared, so combining the denominator since they are the same, so take note the quantity of 6 minus t squared is raised to the power of 2. We have 6 minus t squared, so the exponent of that is power of 2. And we also have here 6 minus t squared, the quantity of that is raised to the power of 2. So therefore, the total exponent now of the quantity of 6 minus t squared will be the power of 4. Okay, so if you want to simplify it further now, our answer becomes 3 times the quantity of 2t plus 3 to the power of 2 times 2t squared plus 6t plus 12 all over 6 minus t squared to the power of 4. Why it's 4? Because the power here is 2 and the power of this 6 minus t squared is also 2. That's why it gives us 4. So next one is in this kind of example, since the numerator is just a numerical coefficient of 2, so the easiest way to do that is to put into the numerator by changing the exponent. So this is what I mean. So I can just rewrite this one as this is just equal to 2 times the quantity of 4z plus e raised to negative 9z to the power of negative 10 or 10. So it's very now easy to solve using only the power rule and then the derivative of the base. So actually we're using the chain rule. So we can write now the derivative of this given function. So we have 2 times negative 10 is negative 20 times copy the base. We have 4z plus e raised to negative 9z to the power of negative 11 because negative 10 minus 1 is negative 11 times the derivative of this base. So we have derivative of 4z is equal to 4 plus the second term of e raised to negative 9z. So we have e raised to negative 9z times the derivative of the exponent we have now. So the derivative is negative 9. So simplifying that one, so we can write now as we have, I'll copy the first part, we have negative 20 times 4z plus e raised to negative 9z to the power of negative 11 times we have 4 minus big Y minus because positive e and to the power of negative 9z times negative 9. So we have now negative 9 e raised to negative 9z. So the next one we have, so I can write now f prime of y. So this is since this is square root, so the exponent now, if we're going to rewrite it this one into fractional exponent, so we can rewrite that one first as the quantity of 2y plus quantity of 3y plus 4y squared close to the power of 3, then this will be, the entire of this will be raised to 1 half. So this is a radical form and this is not fractional form or fractional exponent. So using first the power rule, we have 1 half times the coefficient of this quantity is 1. So just write here 1 half times copy the entire of the radicand, we have 2y plus the quantity of 3y plus 4y squared. This this quantity raised to the power of 3, then close bracket to the power of 1 half minus 1 is negative 1 half times the derivative of this. So I can use the bracket. So we have the derivative of 2y is just equal to 2 plus, since there is a quantity here to the power of 3, then I will apply first the power rule. So this becomes 3 times, copy the entire of this. All right, so this will become 3 times, we have 3y plus 4y squared close, and this will be to the power of 2. Why power of 2? Because the exponent here is 3, so minus 1, so it becomes now the power of 2. But we are not yet done yet because oh, we need to take again the derivative of the base, which is this one. Okay, so multiplied by, I will just write it here. So derivative of 3y is just 3 plus derivative of 4y squared is equal to, we have 8y. All right, so rewriting that one now, so we can write now as f prime of y is equal to, we have, I'll copy this one, so we have 1 half times the radicand itself, we have 2y plus the quantity of 3y plus 4y squared to the power of 3. There is an exponent of negative 1 half. And then simplify this one. We have the next term is 2. So I'll copy 2 plus. So this one will be combined together. We are going to multiply this one. So multiply this one and with that. So you can only multiply here the monomial with this binomial. So the product for that now will give us 3 times 3 is 9 plus 3 times 8y is plus 24y times, you copy the next binomial, we have 3y plus 4y squared to the power of 2. But let's try another one. So we have y is equal to tangent of this angle. We have the cube root of 3x squared plus ln of 5x raised to the fourth power. So we have y prime is equal to, first, we are going to take the derivative of tangent. And we know that the derivative of tangent is equal to secant squared of the angle. So I'll write first secant squared. So we have secant squared of the angle, copy this one. We have the cube root of 3x squared plus ln of 5x to the fourth power times, we are going to take now the derivative of these terms. So on the first term, that's cube root. So express that one in your mind as fractional exponent. So that would become now as 1/3 times 1/3 times we have 3x squared to the power of 1/3 minus 1 is negative 2/3 times the derivative of 3x squared. So if you are going to use the chain rule, take note in chain rule, we have power first. If there is a trigonometric function, so trigonometric function, and then the angle. If there is no exponent, so that's why you are going to start first with the trigonometric function. Now, if we have here the fractional exponent, so start first with the power rule and then the angle. So the base now here is 3x squared. So derivative of 3x squared is 6x. So we have to multiply by 6x. So we are done on the first term. So plus next now on the second term. So ln of 5x raised to the fourth power. So with this ln, you take the reciprocal of the angle. We have 1 over 5x to the fourth power. And then take the derivative of 5x to the fourth power. So it gives us now times we have 20x cubed. Close. Now, simplifying further, so we can write now, I'll copy the first few terms. We have now secant squared of the, the angle, which is now the cube root of 3x squared plus ln of 5x the fourth power. And then we will just simplify now inside the bracket. So 1/3 times 6x, we have now 2x times 3x squared to the power of negative 2/3 plus we have 20x cubed times 1 is 20x cubed divided by 5x to the fourth power. So 20 divided by 5 is 4. And then it should be x cubed divided by x to the fourth power is over x. So you can, instead of writing 4 over x, you can write now as 4x to the power of negative 1. So that would be now the final answer. Okay, looking at this class, so we have sine cube. So since this is the power of sine is the third power, start first with the power rule. Okay, unlike a while ago, the tangent has only first power. So that's why we take right away the derivative of the tangent, which is now the second squared of the given angle. Now, in this case, so since the exponent of the trigonometric function is the power of 3 or greater than 1, then you need to take first the power rule. Okay, so we can write now as 3 sine squared because 3 minus 1 is sine squared, and then copy the measurement of the angle. We have e raised to 1 minus t plus 3 sine of 6t. Now next we have to take the derivative of the trigonometric function. So what's the derivative of sine? So the derivative of sine is cosine. So I can write now here cosine and copy the measurement of the angle. Okay, cosine of e raised to 1 minus t plus 3 sine of 6t, which is the measurement of the angle of the sine. Now, after that, we still need to take the derivative of the angle. Okay, so this is now the, we're going to take here now the derivative of the angle, which is this one. All right, so since they are binomial, so we have to take now, we have plus, and start first on the first term, we have e raised to 1 minus t, and then take the derivative of the exponent. because we know that derivative of a raised to u times du. It means to say we take the derivative of u. So our u there is 1 minus t. So derivative of 1 minus t is negative 1. So we have here negative 1. So we are done on the first term. And then plus we have 3 sine 60. So let's start first thinking the derivative of sine. So derivative of sine is cosine. So copy the numeric coefficient. I can write now as 3 cosine of 6t. And the last one is taking the derivative of the angle of the sine. So the angle now is 60 and the derivative of 60 is just 6. So times 6. So that is the long process. Okay, let me recall again. So first, you are going to take the power rule if there is the trigonometric function. So use first the power rule. That's why it becomes now 3 sine squared. Then copy the angle. Next is take the derivative of the trigonometric function. So derivative of sine is cosine and then copy the original angle. And the last one is to take the derivative of the angle. So we have on the first term, we have e raised to 1 minus t. So copy that one, e raised to 1 minus t, but e raised to 1 minus t, the exponent is still differentiable. That's why we take again the derivative of 1 minus t. So derivative of 1 is 0 and derivative of negative t is just negative 1. So we are done on the first term of the measurement of the angle. Now, on the second term, we have 3 sine 60. So first, think about the derivative of the trigonometric function of sine. So derivative of sine is cosine, and then times 3, copy the numerical coefficient. We have 3 cosine of the measurement of the angle, which is 60. Now, last one is to take the derivative of the angle of this sine 60. So, the derivative of the angle of 60. So, derivative of 60 is just 6. Now, simplifying that one now, so what I will change only, we have negative 1 here. I will just multiply the exponent of the derivative of negative 3, negative 1 to our coefficient of 3. Or if you don't like, you can also write here as negative. So I will write first negative before writing it here. So our final answer now will become g prime of t is equal to 3 sine squared of e raised to 1 minus t plus 3 sine of 6t plus the second term, we have cosine of e raised to 1 minus t plus 3 sine of 6t. So no need to multiply negative 1 to the 3 here because it's quite far. So just multiply it there. So positive times negative, it becomes now negative of e raised to 1 minus t. And 6 times 3 is 18. So we have 18 of cosine of 6t. So that would be now the final answer. So that is usually what will happen if we are going to solve for using the chain rule.